Hey guys, we're gonna do chapter 1 video, okay? So if we look at these, I just recategorized these. It should be pretty consistent. We are gonna do these questions for chapter 1 on this video. 14, 19, 23, 28, 39. So feel free to forward, rewind, whatever you need to do to double check your answers on these questions. And good luck. Hopefully you got some of these right. So question number 14 says, to illustrate the danger of using a regression equation to make a prediction that are outside the range of data, an AP Stats teacher used data on an X and a Y. X is year and Y is median for the years between 1997 and 2007 to fit a least squared regression line. Okay, so I actually mislabeled this one. This one is actually a chapter 3, but we'll just press on. So it looks like we have year here on the X, and on the Y we have the median home value. And we predict as a year goes on, maybe there's a little drop, but as these years go on, the median home value goes up, right? During this time period, the median price increased each year to the next. The line was then used to predict the median house price for 08, 09, 10, and 11. So we always want to be careful in chapter 3 that we don't extrapolate, meaning whatever data we collect, whatever dots that look like they form some kind of a line of best fit, we don't really want to go beyond or very much beyond the values for X to the left or the right. So during this time period, housing prices declined significantly, which was true. Housing prices went down during these years. Which of the following best describes how the predicted median price compares to the actual? Okay, so if we graphed the actual based on the information they gave us, and I actually lived this, if we went 97, 98, 99, 2000, 01, all the way to 07, right? All the way over here to 07, 08, 09. And 11. When we look at this, they've told us that, maybe the data that was collected is gradually going up over time. Except when we got to 7. And then in the years 08 and 09, there was some kind of a decline, right? Which of the following best describes how the predicted median prices would compare? So our line of best foot would have been here, meaning all of our values would have been negative residuals. So if it declines when we thought it was going to increase, notice these residual values are negative. So on our formula sheet, we see that a residual is our actual minus our predicted. So it says, the predictions would tend to be greater than the actual value and would be closer to the actual values. The predictions would tend to be greater than the actual values and would be closer to the actual values in 08 to 11. Some of the predictions would be greater than and some would be less. No, because we said that it declined. So we don't like A. We notice that if it declines, then all the predictions are negative. In B, it said the predictions would tend to be less than the actual. No, these are actually the predicted values here. And the yellow ones are the actual. So We don't like this one. The predictions would tend to be less. No, our predictions, if we thought the trend was keep going up, our predictions are higher. The predictions would tend to be greater. Okay, so we like D. Than the actual values, and would be closer to the actual values in 11 than in 08. The predictions, so we like E the best. The predictions would tend to be greater than the actual, and we'd be closer to the actual value in 08 to 11. Okay. So because the prices were increasing, right, in this duration, from 97 to 07, the slope of the regression line would be positive. This means the predicted values would continue to increase as we extended past 07. But because the prices actually declined from 08 to 11, the predictions would be too large, and the predictions would be farther from the actual value in 2011 than in 08. They would be farther from the actual value. I like it if this said the word farther. That's my only hang up here. All right, next question. Question 14 was chapter 1, so it looks like this one's chapter 1. Question 19 says, wheelchairs have braking mechanisms that minimize speed as they go downhill. Okay, so that makes sense. If you were riding in a wheelchair and you were going downhill, there's a way to kind of brake this so that you don't go out of control, right? In order to test how long it takes different wheelchairs to come to a complete stop after going downhill, a consumer group tested 20 different wheelchair models on a ramp. The tester rolled down the ramp, then applied the brake when they reached a white line. So they started whirling downhill, and they came to a white line, and that's when they started applying the brakes. And the distance from the white line to where the wheelchair came to a complete stop. So this is this distance they're trying to measure. How long did it take to stop? A relative frequency histogram is of the stopping times is shown below. So a frequency would just mean the actual value, and relative frequency would tell me relative to the rest of the data. So it looks like 5% of the time, the stopping distance was 1. 15% of the time, the stopping distance was 2. 40% of the time, 10% of the time, 15% of the time. Notice all of these have to add up to 1. And 5% of the time. So even though we don't have the raw data, we can assume that if we did it 100 times, then this would have been 5 of the 100, 15 of the 100. You get the point. So relative frequency helps us calculate the percent of the time, and that's actually probably more valuable than actual raw frequency. So now they ask, what proportion of wheelchairs tested were able to stop in 3.5 feet or less? All right, since these are already, so 3.5 feet, so 3.5 feet or less. We have the quantity. This one is less than, because it's 3. This one is less than, because 2 is less than 3, and that one is less 1. So our percentage of 3.5 x is less than or equal to 3.5 would be the probability of 3 plus the probability of 2 plus the probability of 1. And we get 60, right? Next question. It says below is a relative frequency distribution, and that's what we just got done looking at. Again, it's a chapter 1 question. So it looks like there was a study of 8. So how did they get that number? 8 divided by 50. And that should make sense. So again, this was our raw data that we collected, and they turned it into percentages so we could see what proportion was each interval. Notice this should add up to 1, right? According to the table, what percent of families in this study had more than 2 cars? So greater than 2 cars. So 3 is greater than 2, right? And 4 or more is greater than 2. So that'd be x is 3 plus x is 4 or more. So we get 14 and 6. And it says what percent, right? What happened here? Oh, bumped it. Okay, so 23, that's question. So we continue to look for chapter 1 questions. We find a stem and leaf plot. As part of an adult education stat class, the professor asks the students in each of her 2 sections to report their age. She then constructs a back-to-back stem plot. This produces 2 sections. So this is section 1. It looks like this is kind of a typo. I think this is section 1 on the left, and this is section 2. There was some kind of a tabbing mistake there. All right, if the 2 sections were combined into a single data set, what is the mode? And mode is the number that happens the most. So we have, this is the number 19, and another person in section 2 had the number 19. So right now that's the most, because 19 happened twice. Look for another one though, right? This is the number 22. Okay, so that happened twice, and that's so it's kind of tied. Ooh, but I found a bigger one, right? This is the number 29. That happened twice, and in section 1, and once in section 2, so that's going to be our mode. Okay, so we like this one. We didn't even see 19, so I shouldn't have even interviewed it. The number 9 is actually not in the data set at all, and the number 0 is not in the data set. So 29 comes up 3 times. Now let's look for the number 30. So that's this number, 30, 30, 30. So you have 3 30s in section 2 and no 30s in section 3. So that one also comes up 3 times. So I have a feeling 33 is our answer. Let's just make sure. This number 33, 33, 33, 33. Yep, there's 2 43s in each, 2 33s in each section for a total of 4 times. So 28 is E. That is the mode or the number that happens the most. All right, any other chapter 1 questions? Here we go, question 39. It says, after showing up late for work again, Lafayette is called into his boss's office. The boss presents him with a cumulative relative frequency test. All that means, the last 2 questions we did were relative frequency. That means this was 4%, or if he showed up to work 4 out of 100 times, he showed up to work at 8:45. So let's read, though, what it means by 8:45. It says, in each case, it's based on the time that the system clocked him in. The system records time rounded to the next 15-minute interval. So if Lafayette clocked in at 8:51, it would round up that he arrived at 9. Okay? So if he clocks in anytime before, so this would be, maybe 8:40. Anytime before 8:45, it's going to round up to the next 15 minutes. Here, this is 15, so I know what got it added to it. That's 11, so 11% of the time. So if his boss took notes of 11 days, 11 out of those 100 days, he must have come in sometime after 8:45, so maybe 8:46. Notice the clock rounded up to 9. All right, the next one, 27. So 27, take away 15. That means 12% of the time he showed up sometime after 9 o'clock. So that could be any time after 9:01. Then we get 61. So if I subtract that, I get 432. So that looks pretty often. Oh, this is over 100. 12 over 100. Sorry. 34 over 100. They show up sometime after 9:15. So 9:16 or any time after. Then 83 take away 61 would be 22. So 22% of the time he's showing up sometime after 9:30. So maybe 9:31, anytime between then and 9:45. And this last little bit would be 17. So that's what they mean by cumulative relative frequency, and that's anytime after 9:45. So it's saying, just so you understand what kind of a chart you're reading, it says, according to the chart, during what time interval is Lafayette most likely to clock in? So if we look at our data here, this is this time interval. So anywhere between like 9:16 and 9:30 is the one that's the most frequent. And we just double check that as our answer. And it looks like, yes, that's our answer C. Now I didn't copy it, but number 40, I tried to save paper. That one fell in the next section. So that's all of chapter 1.